It stands on the tarmac, a magnificent creature of metal and wire. A commercial airliner is one of humanity's most extraordinary achievements. It seems almost too heavy, too immense to ever leave the ground. Yet, with a roar, it begins its journey, accelerating, then lifting into the sky. This is not just a machine, it's a testament to human ingenuity, a symphony of physics and engineering. Every part, from nose to tail, has a purpose. The immense weight, the fuel, the cargo, and every soul on board, all pulling it down. Yet it soars. It pushes through thin, cold air at hundreds of miles per hour, miles above the world below. This feat is the result of over a century of innovation. The pioneers of aviation could only dream of such a vessel. Today it connects continents and cultures, but its familiarity shouldn't diminish our sense of wonder. To truly appreciate this marvel, we must look closer and discover the secrets within its design. The journey of an airplane is a dance with the laws of nature. It starts on design tables and in wind tunnels, where engineers perfect every curve and angle. The wings, the body, the engines, all meticulously calculated to work together. As we watch it ascend, we witness the culmination of dreams and immense collective effort. This flying machine is more than transport. It's a symbol of our desire to explore and connect. And so, our journey of discovery begins as we peel back the layers of this incredible creation. The main body of the aircraft is called the fuselage, a long, hollow tube of strength and sophistication. Its cylindrical shape withstands pressure differences at high altitudes and slices through the air with minimal drag. The wings are the heart of flight. Their curved airfoil shape creates lift, allowing the plane to rise. Wings flex and bend, absorbing turbulence like a bird's, making flight smoother and reducing stress on the structure. Inside the wings are fuel tanks, balancing the aircraft and reducing bending forces. At the tips, winglets reduce drag and save fuel. At the rear, the tail assembly, vertical fin and horizontal stabilizers, provide stability and control. The vertical fin prevents yaw. The horizontal stabilizers prevent uncontrolled pitching. Movable sections, the rudder and elevators, let the pilot steer with precision. Every surface, every angle is designed for efficiency, safety, and control. The fuselage holds everything together: passengers, cargo, cockpit, and systems. The wings generate lift but also house fuel and flex for stability. The tail keeps the aircraft steady, allowing for smooth, controlled flight. All these elements work in harmony, making flight possible. The design is a balance of power, efficiency, and safety. Each part is essential, each function carefully considered. The result, a machine that conquers the sky with grace and reliability. This is the genius of modern aviation. The roar of an airplane comes from its engines, the powerhouses that provide thrust. Most modern airliners use turbofan jet engines which suck in air, compress it, mix it with fuel, and ignite it to create a powerful jet of hot gas. The majority of thrust comes from bypass air accelerated by the fan, making engines quieter and more efficient. Engines are often mounted beneath the wings, relieving wing stress and aiding stability. This placement also keeps engines accessible for maintenance and clear of the ground. Some aircraft mount engines at the rear, creating a clean wing for maximum aerodynamic efficiency and a quieter cabin. Each engine placement has trade-offs. Tail-mounted engines require a stronger tail and are harder to access. Engineers weigh performance, safety, and practicality for every design. The final configuration is always a carefully considered compromise. Whether under the wing or at the tail, engine placement shapes the aircraft's performance and character. Every choice is about balance, efficiency, safety, and the mission of the plane. Propulsion is more than power, it's a masterpiece of engineering. It's what makes flight possible. Step inside an airplane and you enter a world designed for safety and comfort, high above the earth. At cruising altitude, outside air is too thin and cold, so the cabin is pressurized with cooled, filtered air from the engines. The air is refreshed every few minutes and passes through hospital-grade HEPA filters, capturing over 99.9% of airborne particles. Seats are engineered to withstand immense forces. Tray tables and overhead bins are designed for safety. Oxygen masks use chemical generators providing air for 12-15 minutes, enough time for pilots to descend to safety. Materials throughout the cabin are flame retardant, and lighting can switch from calming to emergency bright in seconds. Every sign, handle, and latch is placed for intuitive use in emergencies. The cabin is a life support system, protecting us in a hostile environment. Every detail is engineered for safety, comfort, and peace of mind. It's a protective shell, letting us travel the skies in comfort and security. The cockpit is the brain of the aircraft, where human skill meets computerized precision. Pilots sit before digital displays showing speed, altitude, engine data, and navigation. Controls, yoke or side stick, rudder pedals, and throttles allow precise maneuvering. Autopilot systems can follow flight paths, manage speed and altitude, and even land the plane in low visibility. Pilots remain in command, monitoring systems and making critical decisions. The black boxes, voice and data recorders, are virtually indestructible, preserving vital information for safety investigations. Every tool in the cockpit is designed to enhance safety and efficiency. It's a place where technology and human expertise keep flight safe. An aircraft is a fortress of safety, equipped with systems most passengers never see. Lightning strikes are harmless. The metal skin acts as a Faraday cage, channeling electricity safely away. De-icing systems use hot air from engines to keep wings and inlets clear of ice, ensuring safe flight in freezing conditions. Emergency lighting strips guide passengers to exits if power fails. Overwing exits and main doors have inflatable slides that double as life rafts. Windows have 3 panes, a tiny bleed hole equalizes pressure and prevents fogging. Every detail, from exits to windows, is engineered for safety and reliability. Redundancy is built into every system. If one fails, backups take over. Even the smallest features, like window holes, play a vital role in safety. The aircraft is designed to handle the unexpected. Safety is never left to chance. Every flight is protected by layers of invisible technology. That's why air travel is so safe. Commercial aircraft are filled with clever hidden features. Crew oxygen systems use dedicated tanks for longer emergencies, and pilots' masks protect against smoke. Cockpit windows can open for emergency escape, with ropes or slides for evacuation. Life vests have manual inflation tubes and water-activated lights for rescue visibility. Even ashtrays and lavatories remain, providing a safe place to extinguish cigarettes if someone breaks the rules. Every detail, even the unexpected ones, is about safety and preparedness. These features reflect hard-earned lessons and a commitment to safety. Every inch of the plane is designed with care. The airplane is a masterpiece of integrated design, not just a collection of parts. Wings generate lift and store fuel, engines provide thrust and bleed air for pressurization and de-icing. The fuselage houses passengers and forms part of the lightning protection system. Every material is chosen for strength, lightness, and durability. Redundancy is everywhere, backups for every system. Each generation of aircraft is safer, quieter, and more efficient. Air travel is now one of the safest forms of transportation. Next time you see a plane, appreciate the brilliance behind every detail. It's a flying city, a scientific marvel, and a work of art. Understanding airplane engineering reveals a world of wonder. Every hum, every flexing wing, every view from the window is a lesson in science and design. This appreciation sparks curiosity about air traffic control, pilot training, and future innovations. Aviation is where physics, engineering, and human factors meet. These machines connect our world, making the impossible routine. Knowing the care behind every detail replaces fear with awe. Let this inspire you to look up and see not just a plane, but a story of human ambition. The next time you fly, remember the hidden systems and century of innovation that make it possible. The sky is just the beginning of discovery. The horizon awaits, full of wonders yet to be understood.